Respected dignitaries, a warm good morning to everyone. My name is Shailu and my paper presentation on an efficient retinal layer segmentation based on deep learning regression technique for early diagnosis of retinal disease in OCT and fundus images. And the authors of my paper are L. Shibayamini, G. Viveka, J. Sai Dheeraj and H. Srihari. And these are the contents of my paper presentation. And the main objective of my paper presentation is to automate the segmentation of retinal layers. We propose deep retina, a method based on deep neural networks through which we classify different types of disease by giving fundus of OCT images as the input. We are using deep learning methods for getting the optimum output in which algorithms get trained and get to know what type of eye disease. And we know that OCT means OCT images as the input here, and deep retina uses the improved extraction 65 to extract and learn the characteristics of retinal layers. The exception 65 extracted features maps are imputed to an atrios spatial pyramid pooling module to obtain multi-scale feature information. Moving to introduction. In developing countries, retinal illness is a primary cause of vision loss and permanent blindness. The World Health Organization estimates that 36 million people worldwide are permanently blind, with a total of 253 million individuals suffering from vision impairment. Appropriate retinal screening and treatment planning can prevent up to more than 80% of visual impairment situations. In the early stages, the retinal pictures obtained by optical coherence tomography must, however, be examined by an expert ophthalmologist for early diagnosis. By the evaluating changing in the retinal layer thickness, early identification of retinal disorders such as glaucoma, diabetic retinopathy, age-related macular degeneration, and even cognitive degeneration disease such as dementia has been demonstrated to be beneficial. There is no visible evidence in the retinal structures in the early stages. Early diagnosis is achievable, however, by establishing the precise changes in the retinal layer. As the result, measuring the retinal layer thickness is good useful for the early diagnosis and determining disease progression in order to develop an effective treatment plan. Layer thickness is measured using a segmentation procedure. Hence, layer segmentation is important for diagnosis and treatment planning. While human segmentation takes time and the comprehensive techniques allows for the diagnosis of a huge number of photons. And we can see the mass, the first sign of doctor appears as a reddish and smaller and circular dots. They usually appears as a bright red spots, patches with substantial variability in shapes and appearance. And this is the introduction. Moving to the existing methods, OCT segmentation algorithms in general, it can be divided into two categories. One is algorithm driven approaches and another one is data driven approaches. In first one, algorithm driven approaches, the first category includes early algorithms such as those based on edge detection, edge threshold and computational geometry. Later algorithms includes graph search, active counter and kernel based method. Although these algorithms partially segment the retinal images, they fail in most practical cases because of their prior assumptions and fixed mathematical models. Moving to the second one, that is data-driven approaches. In the second category, it employs artificial intelligence techniques which have recently attracted considerable attention in both industry and academia. Therefore, studies on the development of segmentation approaches have gradually shifted to deep learning techniques. Diverted to deep learning networks are employed in many medical images analysis tasks. A 3D convolutional neural network is applied to diagnose attention deficit hyperactivity disorder in functional and structural magnetic resonance imaging. And these two are the existing methods. Moving to the drawbacks, these are the drawbacks of existing methods. The main Drawbacks are failure to detect microaneurysms and ambiguity in detection and limited dynamic range and retinal disease detection and classification performance is poor. Accuracy of retinal disease detection is low. These are the drawbacks of existing system. So later we propose some methods. In the automation era of electronics where everything goes automatically even in the absence of a person with a super accurate manner providing the best outputs. With the help of deep learning concept using MATLAB we can make the work automated and getting the optimum output and an exact estimation results. Here we are generating the retinal analysis by the image processing method of segmentation. We compare the results of fundus images and OCT images and check where the accurate results appears by the usage of deep learning. And so these are the proposed methods. Moving to the methodology, here we can see that the methodology is given below as a step-by-step procedure. Firstly, the specifications of MATLAB or 2016 are to be specified based on the literature survey. Secondly, based on the specification, the particular device technology is to be selected. Thirdly, the database of different fundus and OCT images are required to be collected. Finally, our fundus and OCT images comes analysis with the database already exists providing the accurate results of retinal problems. This is the methodology. Here we can see the 4 steps in this methodology. Later moving to the block diagram, here we can see in block diagram we can see OCT and fundus images, pre-processing and image filtering and image segmentation, object clustering and edge detection and boundary tracking. The main aim of the proposed methodology is to identify and forecast the health issues related to OCT and fundus scan images. The input medical image is captured by the help of medical imaging modified and it is important for the medical database. The acquired image is subjected to the pre-processing methods in order to reduce the noise and air gaps that might have included into the medical images during the capturing process. Here the advanced filters such as median in combination with contrast improvement algorithms are utilized for the purpose of pre-processing. Later we can say the training features, feature extraction and morphologic enhancement, candidate lesion detection. And here also we can see the CNN classification, that is diabetic retinopathy, glaucoma and dementia and macular degeneration. Further, the resultant image is subjected to image segmentation in order to obtain the layers in the images and clustering operation is carried out to obtain the objects of the medical image. In correction to this edge detection process is applied to the resultant images in the clustering operations for the purpose of tracing in the boundaries. This aids the method to detect the lesions of the image. So this is the black diagram. Moving to the advantages and applications, these are the advantages. One is it has a high dynamic range, it has high resolution and has accuracy of retinal disease detection is high and has high performance efficiency. Moving to the applications, it has ophthalmology and dermatology and also in uses in cancer diagnosis and early diagnosis of retinal disease such as glaucoma, diabetic retinopathy and age macular degeneration. These are the advantages and applications. Moving to the here we can use the tools, that is software component, description of component, and here we can use the MATLAB or 2016 version tool installed in PC. Because of for use stimulation process, here we can use the MATLAB. And these are the references of this title. At last, I conclude that the proposed method involving regression techniques as mentioned in the paper mainly undergoes 4 important stages. In the first stage, the pre-processing of the OCT scan images and fundus images scan is pre-processed by means of advanced filtering techniques in order to remove the artifacts that have been added during the capturing of the image. In the second stage, segmentation and clustering in cascade out of the resulted image via edge detection. In the third stage of feature extraction, the significant attributes such as layers in the macular region are generated. In the final stage, CNN classification is carried out, which is mainly based on training and testing with the features and has been generated from the early stages further based on the features, the type, alignment in the OCT and fundus images are classified. So this is the conclusion of the title. Thank you.